everyone, welcome back. This is second lecture of electrostatics. In the first lecture, I taught you about charge. What is charge, properties of charge, ways to charge a body, what is difference between charge and mass, all those things we have done in lecture 1. In this lecture, I will be teaching you Coulomb's law. In fact, for Coulomb's law, I will be taking out 3 videos. In the first video, I will talk what is Coulomb's law and we will solve some basic problems. In second and third lecture, we'll take a bit better question, good questions, advanced level questions, in which I will be connecting this Coulomb's law with kinematics, friction, center of mass, momentum, SHM, energy. We'll do some questions which requires integration, finding force between a point charge and a line charge, point charge and a semicircular ring. All those things we'll discuss. So today's lecture will be very basic. We'll learn what is Coulomb's law, we'll do some graph and we'll do some basic problems. Okay, now one thing you all keep in mind, that laws are based on experiment. We don't have any derivation, it's completely experimental. Now if you remember, in the previous lecture I taught you, if we have like charges, they repel each other. Like charges repel each other, unlike charges attract each other. But by what force, that we have not discussed. So that is given by coulombs. Okay, I can show you one experimental setup. It will be easier for you to understand. Let's say we have two positive charge Q1, Q2. Okay, this charge is connected with a machine. This also connected with a machine. Now the work of this machine is to maintain the net force on the charge 0. Like this Q1 charge will repel this Q2 charge, let's say by 10 Newton force. But this machine work is to maintain net force 0. So if this charge is applying a force on this charge, let's say 10 Newton away, because it will repel, this machine will create a force 10 Newton in opposite direction, so that the net force on the charge is 0. So whatever force this will apply on this, to maintain this charge particle at rest, this machine will apply the same force in opposite direction. So whatever force this is applying, same machine is applying. So by seeing the reading of the force on this machine, I will understand how much force the charges are applying on each other. And what we observed, whatever force Q1 applied on Q2, same force Q2 applied on Q1 in opposite direction. That's what we obtained. Okay, now we will connect this with a scale as well. We will connect this with a scale as well, because this force depends upon distance also. Okay, so what we observed, the force between the charges were proportional to Q1. What does that mean? When I increase the value of Q1, what I observed, this force increased as well as this force also increased. The forces between the charges was proportional to Q1. Same I observed, when I increased the value of Q2, again the force increased on both the charges. It means the force between the charges was also proportional to Q2. And when I kept Q1 and Q2 constant and I changed the distance, this is a scale. If I change the distance between the charges, then I got to know that force was changing as 1 by r square. If I decrease the distance, force was increasing. And how this force was changing? Proportional to 1 by r square. It means if I do distance double, force will become 1 upon 2r square, means 4r square. Force will decrease by 4 times. This is what we observed with the help of this setup. Okay, so from here what I can say, the force between two charges was proportional to Q1, Q2, the product of the charges. It was proportional to Q1, it was proportional to Q2. So I can say the force between two charges is proportional to Q1, Q2. And also this force is proportional to 1 by r square. This is what Coulombs obtained experimentally. Clear? Pause and you can draw this diagram. Okay? So, if we have two charge, Q1, other charge Q2, kept at a distance r, then let's say both are positive. So Q2 will repel Q1. This is force on 1 due to 2. And at the same time, Q1 will repel Q2. This is force on 2 due to 1. Force is a vector quantity. Put a vector above this. The magnitude of this force on 1 due to 2 was equal to the magnitude of force on 2 due to 1. Whatever force 1 was applying on 2, same force 2 was applying on 1. In vector form, I can write force on 1 due to 2 was equal to minus of force on 2 due to 1. This is what we obtained experimentally. And the value of this force, the magnitude of this force came proportional to the product of the charges, as I told you on the previous slide, and this force also came proportional to 1 upon r square. On combining these two, we will get force proportional to Q1 Q2 by r square. When we remove this proportionality, we get a constant. The constant is K, and this K is known as proportionality constant. This is the formula of force between two charges. You can write the statement. The force between two charges, write the statement of Coulomb's law. The force between two charges is proportional to product of the charges, and inversely proportional to square of distance between them, and this K is known as proportionality constant, and this K depends upon medium. We will learn about this. Okay, medium will not come today. Medium will come after 2-3 lectures. We'll discuss. Right now, whatever question we are going to solve, in all the case, we will assume that the particle is present in air or vacuum. Okay, right now, in all the cases, the charged particle will be in air or vacuum. You all have to remember one more thing, the value of K. I told you K depends upon medium. So by changing medium, the value of K changes. But as I told you, in next 2-3 lectures, we will solve all the problem in vacuum or air. Nearly they are same. So in this case, the value of K is 9 into 10 power 9. And what will be the unit of K? So force you can find from here. What will be K? K will be force into distance square by Q1 Q2. So force will be Newton, distance square means meter square, divide by charge into charge, Coulomb square. Clear? You can just write the value of this K. 9 into 10 power 9 Newton meter square upon Coulomb square. Next. Clear? Pause and write. Next. This Coulomb's law, which we are saying as F is equal to K Q1 Q2 by R square, keep in mind the charges has to be point charge. Coulomb's law is applicable only for point charge. This force K Q1 Q2 by R square, the charges has to be point. Q1 Q2 has to be a point charge. Now if I ask you what is the meaning of point, if I draw 4 diagram, 1, 2, 3, 4. Out of these 4, which is point? Think. Listen. All 4 can be point. All 4 cannot be a point. Let's say you are seeing from a far distance. From far distance, even a building seems to be a point. If you are far away and see a building, it seems to be a point. Is it? So from far distance, all will be a point. And from a very close distance, let's say for an insect, if an insect is sitting here, for the insect, this will not be a point. It will be a big disk. Is it? So point is what? A relative term. Okay. So I told this formula is applicable only for point charges, which means if I am sitting on charge Q1, Q2 should be like a point, and if I am sitting on charge Q2, Q1 should be like a point. They can give you question कि two buildings having charge 10 coulomb are separated by a distance of 100 kilometer. Find force between them. Now don't say sir building is not a point charge. If two buildings are so far, you sit on one building, other will be like a point. And you sit on this building, this will be like a point. This is the meaning of point. From one body, other should look like a point. Clear? So this Coulomb's law is applicable only for point charges. You all right? Coulomb's law is applicable only for point charges. From one body, other should be a point. From this body, this should be a point. Now second, let's say both are positive charge. So you know positive charge will repel positive charge. My question is in what direction? Like this Q1 and Q2 both are positive charge. This Q1 can repel Q2 like this. It may repel like this. It may repel like this. It may repel like this. Which is correct? This is correct. This is wrong. The force between the charges will be always along the line joining the charges. You join both the charges with a line, and along the line that force will act. For this body, along the line joining, this force will be always along the line joining, right? Write down. And you know, whenever a force acts along the line joining, the force is known as central force. So we call Coulomb's force also as what? Central force. You all right? The force which acts along the line joining, this force acts along the line joining, and this is known as central force. What force? Central force. Clear? Pause and write. So till now what we learn? We learn that the force between two charges is k q1 q2 by r square. Force is proportional to product of charge, inversely proportional to 1 upon distance square. And the constant k depends upon medium. But right now we will be doing all the question for vacuum or air. In vacuum or air, the value of k is 9 into 10 power 9. Clear? Then I told you this formula is applicable only for point charge. Now what is point charge? When you are sitting on one body, other should be like a point. Clear? Then I told you this force acts along the line joining, and the force which acts along the line joining is known as central force. Clear? One more thing, if I draw two charges Q1, Q2, let's say both are positive, so Q2 will repel Q1, force on 1 due to 2. At the same time, Q1 will repel Q2, force on 1 due to 2. I told you these two forces are equal and opposite. Equal and opposite. The forces are equal in magnitude. Magnitude wise they are equal, but they are opposite in direction. So when you write in the vector form, you have to put a minus sign. So this is also known as what? Action reaction pair. Is it? Third law of Newton. Every action has an equal and opposite reaction. So these forces are what? Action reaction pair. You can write these forces are action reaction pair. Clear? But you know why I wrote this again? Because just saying action reaction pair here is not sufficient. If I just say that the forces between Q1 and Q2 is action reaction pair, so in your mind what will come? That okay sir, action reaction pair means they will be equal and opposite. This statement may misguide you. How? Q1, Q2, force on 1 due to 2, force on 2 due to 1. See, I can say these forces are equal, these forces are opposite, one is up, one is down. This is also action reaction pair. But you know, force acts along the line joining. Force acts along the line joining. This force is not acting along the line joining. So I have to tell the complete statement between two charges. The force which you get F12, F21, these are action reaction pair, but they are equal and opposite, correct? But they act along the line joining. That part you have to add. It's a central force. This is wrong. We know. This is also action reaction. But saying the force is action reaction is not sufficient. You have to specify the forces F12, F21 are action reaction pair and they are central force. Central force means they will act along the line joining. This is correct. Clear? Pause and write. So just saying action reaction is not sufficient. With action reaction, I have to say that this force is what? Central force. Central force means this will act along the line joining the charges. Clear? Okay. One more thing. This electrostatic force, this electrostatic force is a conservative force. Conservative, non-conservative, will learn in class 11 lectures. Okay, what is conservative force? A force whose work done is independent of path. The work done does not depend upon path. Clear? Understood? So it's a central force and it's a conservative force. The work done is independent of path. Okay, we have two forces, na, conservative, non-conservative. What is non-conservative? Like friction, viscous force. Is it the force which takes out energy from the body, which eats the energy from the body? What is conservative force? Conservative force don't take the energy out from the body. They conserve the energy. They just change the energy from kinetic to potential. Like gravitational force, it's a conservative force. If I drop this pen, this pen will come down. Its potential energy will decrease. Kinetic energy will increase. Energy is not going out, it's conserved. Okay, we'll discuss more in that chapter. Okay, right now you all keep in mind electrostatic force is conservative force. Its work done is independent of path. Clear? Till it's clear to everyone? Okay. Now we have some graphical part. You can just pause and write if you want. Okay. Next we have graphical part. I want you all to plot graph between force and Q1. One more thing, keep in mind, whenever you are plotting a graph between F and Q1, Q2 and R will be constant. Okay, this thing keep in mind. Whenever we plot graph between two parameters, other has to be constant. Then you all plot graph between force and Q2. Then plot a graph between force and distance R. And one more graph I want you all to plot between force and charge. Distance is constant, but here in the fourth graph, Q1 is equal to Q2 is equal to Q. Both the charges are changing. Plot these four graphs. Pause and plot. Done? So as we know, force is proportional to Q1. Is it? Force proportional to Q1. Both has power 1, so graph will be a straight line. Then force and Q2, again we know force is proportional to Q2. Again graph will be a straight line. Come to third part, we know force is proportional to 1 by r square. It means as distance will increase, force will decrease. As distance will increase, force will decrease. And it is F proportional to r power minus 2. It will be a curve. So as distance will increase, force has to decrease. The graph will be like this. And when distance will be tending to infinity, force will be tending to 0. Clear? Fourth part is force and charge Both the charge is changing. So we know force is proportional to Q1, Q2, and I have told Q1, Q2 are same, which is equal to Q. So force is proportional to Q square. And we know that y proportional to x square is what? Parabola. So force proportional to y square, Q square. So as charge will increase, force will increase. But how? As y equal to x square. So it will be a parabolic graph. Is it clear? Because both the charges are changing. So force proportional to Q square. Understood? As charge will increase, force will increase. How? Parabolic. Clear? So pause and draw all the four graphs. And next you all write vector form of Coulomb's law. Vector form of Coulomb's law. Okay, so let's see what is vector form. So let's say this is our y-axis and x-axis. Okay, this is origin. Now I have taken two charge particle. First is q1 and second charge particle is q2. The position vector of q1 is r1, okay, and the position vector of q2 is r2. Fine, clear? Now, and let's say from r1, from q1 to q2, the position vector is r. So can you tell me what will be this r? Can I say if I want to start from here and reach q2, how many paths I have? I have two paths, r1 plus r, or directly I can go through r2. Is it? So what I can write, r1 plus r, at whatever point r1 plus r will take me, at the same point I will reach if I go through r2. So here what will be vector r? Vector r will be r2 minus r1. So I can write vector r as what? R2 minus r1. Vector r is what? R2 vector minus r1 vector. Clear? So we have two charge q1, q2. q1 has what position vector? r1. q2 have what position vector? r2. About origin, the position vector is r1, and for second charge, about origin, the position vector is r2. And what is this position vector? This r is r2 minus r1. Clear? How I got that? I went from here to here. I have two paths, r1 plus r, and second part is r2. And I got r equal to r2 minus r1. Clear? Now, in this diagram, q1 will repel q2 along the line joining. Force on 2 due to 1. At the same time, q2 will repel q1. This is force on 1 due to 2. And we know that these forces are action-reaction pair. Whatever force 1 will apply on 2, same force 2 will apply on 1 in opposite direction. Now let's write in the vector form. Pause and write. Now, I am going to write F21. F21. So in vector form, we have two things. One is the magnitude, one is the direction. And we all know for direction, we use unit vector. So let's write the magnitude. What will be the magnitude? You will say K. First charge is Q1, second charge is Q2, divide by distance between them square. I am writing the magnitude. So what will be magnitude? So this vector is, vector R is R2 minus R1. So here we have K, Q1, Q2 upon distance square. Distance will be what? Mod R2 minus mod R1 square. Is it? This is the magnitude. K, Q1, Q2 upon distance square. This is the magnitude of the force. I want direction also. For direction we know we use unit vector. Is it? Now the thing is, I want to know direction of force on 2 due to 1. Look at this. Force on 2 due to 1 is right. Can you see any vector in right direction? Can you see any vector in right direction? Yes. This vector r is also right. Vector r has the same direction as F21. F21 is left, vector r also left. It means to write direction of F21, I can take help of vector r because vector r has the same direction as F21. And who gives direction? Unit vector. So I will take unit vector of r. Listen again. F21 is right. And in the same direction we have vector r. So to write direction of F21, I can take help of vector r. Magnitude I wrote. I need to write direction. Direction is given by unit vector. And in the direction of force, I have direction of r. So I can take unit vector of r. Unit vector of r. And what is r? R is r2 minus r1. Clear? I hope you all know that a unit vector is vector upon its mod. This is known as unit vector. So what I can write this as? Force on 2 due to 1 will be K Q1 Q2 divide by, this is unit vector. What is unit vector? Vector upon its mod. So R2 minus R1 divide by mod of R2 minus R1, and here we have mod of R2 minus R1 square. So what I will get finally? Finally I will be getting K Q1 Q2 R2 vector minus R1 vector divide by mod of R2 minus R1 whole cube. This is the vector form of Coulomb's law. Is it clear? Understood? And how will you remember? Force on 2 due to 1 is K Q1 Q2 R2 minus R1 divided by R2 minus R1 mod cube. Clear? Now from here only, can you write F12? So we all know F12 is minus of F21. Is it? So if I just put a minus, I will get F12. So what you will get? K Q1 Q2 divide by, this is mod R cube. I can write this as R1 minus R2. Mod will be same, is it? The distance between them will be, the mod of distance will be same, is it? I write for F12 or F21. So F12 will be, you can write here, F12 will be minus of F21. Clear? So that minus which I will put, that minus will make R2 minus R1 as R1 minus R2. Is it clear? So I have shown you F21, and I know from third law of Newton, F21 is minus F12. I just multiplied by minus, I send the minus inside, it became R1 minus R2, and I got F12. How will you remember? Same. F12 will be K Q1 Q2 R1, the one on which you are finding the force, minus position of second charge which is applying the force, divided by R1 minus R2 mod cube. Clear? So this is the vector form of Coulomb's law. Just take a pause and complete this. Take a pause and complete this. Clear? Now we will do some questions based on Coulomb's law. Okay? So write question number 1. Question number 1 is, we have 2 electrons which is kept at a separation r. You have to find the ratio of electrostatic force to gravitational force between these electrons. Find out. Pause and find out. Pause and find out. Done? I want you all to find the order of force. It might be a bit calculative. Just find out what order you are getting. 10 power what you are getting. Okay? So let's do it. So electrostatic force by gravitational force will be equal to electrostatic forces K Q1 Q2 by R square. If nothing is mentioned, this will be in air or vacuum. Okay. Divide by G M1 M2 by R square. So distance square gets cancelled out. What will be the value of K? 9 into 10 power 9. Charge into charge. What is charge on electron? 1.6 10 power minus 19 into 1.6 into 10 power minus 19. Divide by G M1 M2. What is G? 6.67 10 power minus 11. Multiply by M1 M2. What is mass of electron? 9.1 into 10 power minus 31 kg into 9.1 10 power minus 31 kg. I just want you to check what will be the order of force, and if this question will come, definitely the options will be far away. If they are not, you have to solve, but most of the time they will give options far away, like 10 power 10, 10 power 20, 10 power 30, 10 power 40, like that they will give. You can just check what will be the order of 10. So here we have 10 power 9 minus 19 minus 19. So minus 38 plus 9, 10 power minus 29. Divide by 10 power minus 11 minus 31 minus 31. So this will be minus 31 minus 31 minus 62, and minus 62 and minus 11. This will be 10 power minus 73. So this will be nearly what? This will go and become 10 power plus 73. Is it? So plus 73 and minus 29, what you will get? Nearly 10 power 44. Okay, so if you see any option between 10 power 40, 41, 42, 43, 44, you mark. It comes somewhat 10 power 42 because we have some other terms as well. Clear? Pause and write. Pause and write. Done? Okay. Next problem. Before next problem, I just want to tell you one more thing. Some similarities between electrostatic force and gravitational force. Both forces varies as 1 by r square. Is it? K q1 q2 by r square. Gravitational force also varies as 1 by r square. This is a similarity. And if any force varies as 1 by r square, we say that the force is following inverse square law. So both the forces follow what? Inverse square law. Clear? Apart from that, both the force act along line joining. Electrostatic force as well as gravitational force act along line joining. Now let's write some difference. What will be difference between electrostatic force and gravitational force? Electrostatic force can be attractive as well as repulsive. Like charges repel, unlike charge attract. But masses always attract. Gravitational force is always attractive. Second, this gravitational force does not depend upon medium. Medium independent. Electrostatic force depends upon medium. Depends on medium. I told you F is equal to K Q1 Q2 by R square. That K depends on medium. But in gravitational force, the force is G M1 M2 by R square. That G is universal constant, universal gravitational constant. In any medium, the value of G is constant. So gravitational force is medium independent. Pause and write. Okay. Next. Let's do some more problems. Next question is, right, Q charge has to be distributed on two bodies kept at fix separation. Find the proportion in which you will find the proportion in which you will distribute the charge distribute the charge for force to be maximum. So on two bodies you have to distribute this q charge. In what proportion you will give the charge so that the force between the bodies is maximum? Pause and try. Okay. So we are having, if I give option, you can get the answer immediately. You know that force is proportional to q1, q2. So you will take the options, you will check in which case q1, q2 is maximum. In that case, the force will be maximum. But how to solve this problem? If you look at this, as I told you, we have to distribute two q charges on two bodies. Let's say first body I gave charge x. So other body will get what charge? Q minus x. And let's say the distance between the bodies is fixed, which is r. Clear? So the force between the body will be what? K. One charge is x, other charge is q minus x divided by r square. This is the force between the bodies. I want this force to be maximum. I hope you all know if we have yx graph, you can see in this graph at the maximum value of y, slope is 0. At the maximum value of y, slope is 0. Slope means differentiation. It means dy by dx will be 0 when y is maximum. Same here also. In fact, in any question, if they ask maximum, minimum, keep in mind, here we have f as a function of x. And I want force to be maximum. For force to be maximum, like here, when y was maximum, dy by dx is 0. Here I want force to be maximum, so I will do df by dx is equal to 0. This r is constant. They have told fixed distance. Look here, the distance is fixed. Fixed separation they have told. R square is a constant. So what you will write? You will differentiate f with respect to x. What is f? Open this bracket. So kq x by r square minus kx square. Differentiate this and make it equal to 0. So kq by r square is a constant. Then we have x. So what is differentiation of kx? K. 2x 2. In the same way, kq by r square into x, if you differentiate, you will get kq by r square. X will become 1. Then differentiation of kx square will be minus, k is a constant. Differentiation of, okay, here also we have r square. So k by r square constant. Then differentiation of x square will be 2x and make this equal to 0. Now here r square will go and become 0, k cancel out. So what we got? We got q minus 2x is equal to 0. Therefore x is equal to q by 2. It means I have to give the first body what charge? First body I have to give what charge? Q by 2. Other body q minus x. So q minus q by 2. Other body also I will give what charge? Q by 2. So keep in mind, when you distribute the charge equally, then the force is maximum. I want you all to keep in mind. You can remember one statement, universe likes symmetry. So when you distribute the charge equally, at that moment the force is maximum. I want you all to keep this result in mind. Multiple times they have given question in competition. So if I say I have to distribute 10 coulomb of charge on two bodies for force to be maximum, you will say, sir, give 5, 5. 30 coulomb, give 15, 15. Is it clear? Understood? Pause and write. And keep in mind, whenever you know y is a function of x and you want maximum value of y, differentiate y with respect to x, make it equal to 0. Here force was a function of x. I want force to be maximum, so I will differentiate force with respect to x and I will make it equal to 0. That's what I have done, and I got x is equal to q by 2. Pause and write. Next problem, question number 3. Third question is, we have two charges q1, q2 at a distance of 1 meter. What will be the minimum forces between the charge? Give your answer in terms of K. What will be the minimum force? What will be the minimum force? We have two charge Q1, Q2 at a distance of 1 meter. What will be the minimum charge? Pause and try. Done. So you will say, sir, force is K Q1, Q2 by 1 square. Okay. I am asking force to be minimum. K is a constant. Distance I have given 1. Now when if force has to be minimum, the charge also has to be minimum. If I give you option, you can do. By seeing the options, you will understand. But try without option. What you will get? For force to be minimum, charge has to be minimum. Remember quantization of charge? The minimum independent charge that can exist is E. So minimum force means minimum charge, and minimum charge will be E. So for force to be minimum, Q1 and Q2 will be equal to E, and the minimum force will be K E into E, K E square. This will be the minimum force. Clear? Keep in mind, the minimum charge that exists independent in nature is E. So when force is minimum, charge is minimum charge is E. Clear? Understood? Right, next problem. Next question is, force between two equal and opposite charge. Force between two equal and opposite charge is F. If 25% of positive charge transferred to negative charge find new force between the charges. One more thing you all keep in mind, very important. Whenever you are applying Coulomb's law, F is equal to K Q1 Q2 by R square, never use sign for solving. You just put the magnitude of Q1 Q2. You just put what? The magnitude of Q1 Q2, and that minus plus we will use common sense to find out direction. Here attraction is there, repulsion is there, that we will find out with common sense. So just write the magnitude, get the force, direction find with common sense. Solve this. So what you will get? Force between two equal opposite charge. Let's take one charge Q, one charge minus Q. Distance they have not given, it means they are not changing. So let's take R. So what will be force? Force will be K Q. I told don't take sign, just write attraction, positive negative attraction by R square. This is what is given. Now what is happening, and very important, many students do silly mistake here. 25% of charge is going from positive to negative. So what is 25% of Q? So 25% of Q will be Q into 25 by 100, which is Q by 4. It means Q by 4 charge is transferring. So what will be the new charge on this? The new charge will be Q, and Q by 4 went, so minus Q by 4. What about this body? People think that here charge will increase. They write 5Q by 4, and I think some of you have done this mistake. But keep in mind, here we have minus Q, and Q by 4 is coming, plus Q by 4. So what will be the final charge? This final charge will be Q minus Q by 4, 3Q by 4. And this final charge will be minus Q plus Q by 4, minus 3Q by 4. Distance is same, R. So what will be the new force? The new force will be K. First charge is 3q by 4. Second charge is 3q by 4. Distance they are not changing. Divide by r square. So what you will write this as? You will write 3 3 is 9, 4 4 is 16, 9 by 16 k q by r square. And k q by r square is f. So in place of k q by r square, you will write f. So new force will be 9 by 16 into f. I hope you understood. Is it clear to everyone? Pause and write. Next problem. Okay, so I planned for the next lecture, but in this lecture only I want to show you that how I can connect the problem of Coulomb's law with kinematics or with center of mass and all. Okay, so let's say we are having two charges, 2 Coulomb, here also charge 2 Coulomb. This body has mass 2 kg, this body has mass 4 kg. The distance between the charges is something, let's say something x, doesn't matter, not required. Okay, clear? Now in this problem, initially time is 0. When time is 0, initially at t equal to 0, the charges are at rest. Okay, you can write at t equal to 0, charges are at rest. Okay, as I will leave, what will happen? Positive, positive, they will repel and start to go away. Is it? This will apply force on this, this will apply force on this, they will start to move away. My question is, after t time, after t time, this body is here, charge is 2 Coulomb, mass is 4 kg, and it's going with a velocity of 20 meter per second. What will be the velocity of this body? At t time, this body is here going with a velocity of 20, and after t time, this body will also move. This will be somewhere here. Is it? What will be the velocity of this body? That's what you have to find out. Understood the problem? At t equal to 0, I drop the ball, I release them, they will repel and go away. Force will be there. Force means acceleration, acceleration means velocity will change. You have to tell me at the instant, at some time t, this body has velocity 20 meter per second, what will be velocity of that body? Pause and try. So what you will get? So how to solve this? Look at this system. We have 2 Coulomb and 2 Coulomb charge. Just now I told you 2 Coulomb will repel 2 Coulomb with a force F, and this 2 Coulomb will repel this with a force F. And as we know, both the force are equal and opposite. So on 2 Coulomb there is a force. On this 2 Coulomb there is a force. But what about this system? The system of this 2 Coulomb and 2 Coulomb? Net force is 0, because on the system this force gets cancelled out. On the system there is no force. On individual balls force are there, but on the system the force gets cancelled out. So net force on the system is 0. Net force on the system is 0. Is it? And we know second law of Newton, force is momentum change upon time. So momentum change upon time for the system will be 0, which means momentum change of the system will be 0, which means momentum initial of the system will be equal to momentum final of the system. Is it? What is the initial momentum of the system? Initial, I told you initially the charges are at rest. So momentum initial will be, momentum is mass into velocity. If the charges are at rest, momentum initial for both the charge will be 0. Rest means velocity 0, momentum will be 0, is equal to, finally at t time, this has what momentum? Mass into velocity. Mass is 4 kg, velocity is 20. So what you will get? 4 into 20. This will be the momentum of 4 kg. and it's going right. Right, I'm taking positive. Momentum is a vector quantity. Be careful with direction. What about second mass? Second charge? I don't know the velocity. It's going left. Mass I know. So what is momentum? Minus mass is 2, velocity is v. Why minus? Because the particle was going left. So from here 0 equal to 80 minus 2v, therefore v is equal to 40 meter per second. That particle is going at that instant with 40 meter per second. I hope you are understanding. So see how I have connected this with mechanics. I can ask you one more thing in the same problem. All of you pause and write. Next part is, in the same problem, the previous problem, data is okay, 2, 2. In the same problem, 2 kg and charge is 2 coulomb, other mass 4 kg, charge is same 2 coulomb. At t equal to 0, I am releasing them. So initial velocity is 0. Okay, at t equal to 0, I will release this charge. At some given time t, now these two charges will feel repulsion. They will go away. Is it? After some time t, this 2 coulomb has reached here. At t time, the 2 coulomb has reached here and it has moved 10 meter. How much at this time t, how much this 2 coulomb has moved, you have to find out. Understood the problem? At time t equal to 0, I have released both the balls. They will feel repulsion, they will go away. At a certain time t, this has moved by 10 meter. You have to find out how much the other ball has moved. Try. Done? So here again same, you can see on the system external force is 0. There is no external force because that 2 coulomb will repel this 2 coulomb with force F, and by the same force this will repel in opposite direction F. So what will be the net force on the system? The net force on the system will be 0. And we know net force on the system is 0, and we know this net force is mass into acceleration of center of mass. F is equal to ma. But for the system, acceleration of center of mass, which will be 0. It means acceleration of center of mass will be 0. What is acceleration? Change in velocity. So change in velocity of center of mass will be 0. Acceleration is change in velocity upon time. Is it? Listen again. On the system there was no force. If I ask you, do we have a force on 2 coulomb? You will say yes. So 2 coulomb will have acceleration, you will say yes. But system don't have any force. On system net force is 0. Force is mass into acceleration. Of what? Of center of mass. I am talking about system. So acceleration of center of mass is 0. Acceleration is velocity change upon time, which means velocity change is 0. And if velocity change is 0, I can say initial velocity of center of mass will be equal to final velocity of center of mass. What was initial velocity of center of mass? Initially I have released them. So initially balls are not moving. So initial velocity of center of mass will be 0. So finally also center of mass velocity will be 0. Understand this thing. Initially the balls are released. There is no velocity for center of mass. And if acceleration of the system is 0, if acceleration of center of mass is 0, it means center of mass cannot move. So velocity of center of mass initially and finally both will be 0. Because initially center of mass was not moving. So finally also center of mass will not move. This will be 0. Clear? To move center of mass, we need acceleration on center of mass. There is no acceleration because acceleration on center of mass will come when there will be external force. We have two forces which are internal, which got cancelled out. So on the system, net force is 0. Force 0 means mass into acceleration of center of mass 0. Acceleration of center of mass 0 means velocity change is 0, which means velocity is constant. And initially velocity of center of mass was 0 because the balls were dropped. So finally also velocity of center of mass will be 0. Is it? It means center of mass is not moving. It means center of mass is not moving. And as we know, displacement of center of mass is mass 1 displacement of mass 1 plus mass 2 into displacement of mass 2 divided by mass 1 plus mass 2. I'm expecting that you should know these things. If not, no issue, you can just go and revise class 11. These are the basic formulas. This is displacement of center of mass. Center of mass is not moving, its velocity is 0. So this term will be 0. So 0 equal to first mass. What is first mass? 2 kg. How much 2 kg has moved? We don't know. Let's say D. And it's going left. So minus D you will take. Plus, what is mass 2? 4 kg. How much mass 2 has moved? 10 meter. Divide by mass 1 plus mass 2, 4 to 6. Therefore, from here, 2D equal to 40. So D equal to 20 meter. It means that 2 kg mass has moved left by what amount? By 20 meter. So you can see I can connect this with any of the chapters. So you should know at least the fundamentals. These are the basic formulas. You should know this. Is it clear? So this was a very basic lecture. In the next lecture of Coulomb's law, I will make 2 more lectures and we'll do some really good problems. But for that, your fundamentals should be clear. All these questions should be clear. Clear? So if you have any doubt, you can write in the comment section. Definitely I will give answer for that and we'll meet in the next lecture. Thank you.